Thank you very much. My name is Sam, and I am an administrator at the Department of Land and Natural Resources in the Office of Conservation and Coastal Lands, and I am...
What's your last name?
Oh, Lemmo, L-E-M-M-O. Good question. And I'm the co-chair of the persons responsible for the development of this report. I have with me Dr. Bradley Romine. He's one of the, he works with the University of Hawaii Sea Grant College program, and he's one of our main contributors to this report. And we have Dr. Kitty Courtney, who's the consultant for Tetra Tech, who is helping us put the report together. Well, she is putting the report together. We're helping her. And there's a bathroom back here for those of you that need to use the bathroom. I want to try to get through this, our presentation, relatively quickly so that we allow some time for questions. I'd like to try to hold the questions really until after we finish our presentation. So you might want to take some notes, you know, if you have a question during the presentation, and then maybe ask the question after we finish. I really don't want to get into a Q&A answer before we finish up here, because then we'll be here all night. And to be honest with you, we do actually have to catch a flight back to Hilo tonight. So we've allocated up to about
45 minutes for presentations.
No, about 2 hours.
Hour and a half.
Hour and a half, okay.
Total.
Yeah.
So thank you very much. And I'm just going to do a little bit of background here. This is, okay, what we're doing is, thank you. First of all, why is this issue so important to us? It's really self-evident, right? But let me just explain a little bit from my perspective. We are an island state. We're the only island state in the United States. We're one of the most geographically remote places in the world. That's great. I mean, I meant that. In this day and age, I'm kind of proud of that. Get as far away from these guys as we can. And then, you know, but you know, we also contribute very little to greenhouse gas emissions. Our carbon footprint is actually pretty small compared to what's happening on the continents with, you know, industries and these types of things. And yet the problem is, you know, islands like ourselves and our sister islands around the world, we're going to suffer some of the worst consequences from climate change. We live in the ocean, and one of the major consequences of climate change is going to be sea level rise. We know sea level rise. Sea level is rising as we speak. It's going to continue rising, and it might even accelerate. People that live on islands are going to suffer the worst. So that's why we have an interest in attacking this problem, understanding the problem, which is what they're going to show you today, and then maybe charting a course forward to do something about the problem for us, so that we can make the impact less difficult in the future. And also, we want to show that we can be an example and a leader in this area globally, that we can, you know, as an island state, isolated geographically, subject to all these problems, that we can actually pick ourselves up by our bootstraps and solve our problems on our own. We're trying to really dance on our feet and adapt and adjust to these rapidly changing realities in the world around us, and so this is kind of part of that effort to move us in that direction. So in 2014, the state legislature passed Act 83, which was the Hawaii State Climate Initiative, and established a committee called the Interagency Climate Change Committee. And that committee was tasked with dealing with helping us manage all of the complex issues related to climate change. You know, not only sea level rise, but the problem with growing temperatures, the problem with water supply, possibly public health issues related to climate change, and many other things, agriculture, invasive species, et cetera, et cetera. But they initially told us, let's focus on sea level rise, because really it's something that is looming literally around our shores. And so we've been working on a sea level rise report for the past 2 years, and we're getting kind of towards the end of that process, and we are scheduled to complete the report by the end of this year. Now, what happened is this last legislative session, the legislature passed another climate bill, which is called Act 32. Act 32 basically expanded the scope of Act 83 by basically saying that we're not only going to focus on adaptation measures to climate change and sea level rise, we're going to focus on mitigation. So the new act basically tells us to not only look at adaptation, but to look at mitigation. As I mentioned, lowering our carbon footprint, becoming more self-sufficient, et cetera, et cetera. Also, this new act established before we had a committee, committee is kind of advisory, right? Now we have a state commission. So it created the state interagency, the state Climate Change Mitigation and Adaptation Commission. And so that commission process is now just getting underway, but I think a commission has a lot more clout and a lot more, maybe a lot more ability to actually do something than a committee. So that's a good thing. And so, but the commission's first task, which is the same as it was under Act 32 and the Interagency Climate Committee, is to develop the sea level rise report. And so we're continuing to move in that direction.
Page down.
Oh, I thought we took that out.
You love that.
Sorry. The dinosaurs went extinct because of a giant asteroid that hit the Earth. And, if you can imagine, if they're standing around kind of talking story and they see this thing coming and, we're going to make it. It's not that bad. Well, this is the biggest fear I have in this climate talk, is that we're going to act like these guys and we're going to say, don't worry, it's not going to be that bad. And then we're going to end up in the same fate as they did. This is just a real simple sort of analogy or metaphor, which I like. Sorry about that. Thank you. Okay, so we have this Climate Change Mitigation and Adaptation Initiative, Act 32. And basically this thing also, in addition to looking at mitigation and adaptation, it's modeled after the Paris Agreement. The Paris Agreement is the big climate accord that was signed into effect by 195 countries. This was done in Paris in 2016. There's a big event later this year in Bonn, Germany, to try to further codify this agreement. So we kind of are trying to implement provisions of the Paris Agreement at a local level. We are the first state in the United States to have legislation that basically talks about the Paris Agreement and tries to implement the Paris Agreement. So once again, leadership, moving forward, being an example of how to do things. All this other stuff I've already talked about. So the report, basically, real quickly, because I'll let them talk about the report elements in detail, is we're compiling the best science on climate change and related to sea level rise, the best science, and it really is the best science, as Brad is going to show you today. We're projecting and modeling exposure to hazards related to sea level rise, and Kitty's going to go over that with you. It's very, very interesting. I do want to note, though, as I said earlier, I met with some people from the county earlier, that because we don't have a lot of sort of certain types of historical data for this island, we weren't able to model certain things to the extent that we modeled those things on the neighbor islands. However, that being said, this report that we're putting out, is a living document and is intended to be updated, almost immediately. And so perhaps we can look at try to get the data for the Big Island that we need to then update the models as they relate to the Big Island. But in any case, we've provided some very valuable modeling for you and some recommendations that can help us all in the future. We're assessing the vulnerabilities in these exposure areas, so we're calculating the economic impact of sea level rise in terms of property loss and structural damages. We're making recommendations to be more resilient, and we're providing a framework so that we can have a more transparent and effective and efficient dialogue about what we need to do to help ourselves deal with these really, really serious problems that we're going to be facing. This is just a real simple conceptual model that we developed at the onset. Stakeholder outreach and engagement. So we've been going to all the islands and talking to not just the public, but also the political leaders and the departments, the county planning departments. And we've also been talking, we've had 2 big conferences on Oahu. Sorry it wasn't held here. We held a couple big conferences on Oahu where we got feedback on the recommendations that we're proposing and helping prioritize recommendations. So there's this kind of stakeholder outreach and engagement process that we're engaged in, and then we're doing a vulnerability assessment, but ultimately this all gets plugged into Living Outputs, which is the report itself. We call it, it's going to be a living report because we don't want it to just go on the shelf. It's not an endpoint analysis. You know, we have to recognize that sea level rise doesn't stop at 2100. And actually projections of sea level rise change daily. And so we have to be able to stay on top of that and make sure that we can adjust our expectations and our modeling to accommodate those scientific discoveries that are happening constantly. We're going around and doing stories. We did a little story for Hawaii County. We came out and interviewed people at the county, and they're giving us some of their sort of advice on what's happening locally, because each place is different, right? We know that, you know, it's not, we can't just put everybody, you know, into the same category. Each island has unique geographic, socioeconomic realities, and so sea level rise means different things to each island depending on where you live. You know, like for Honolulu, you know, you have like, wow, you know, thousands of like, you know, homes along the shoreline, everything's low-lying, huge impact, problem with roads. Big Island, maybe not the same type of problems. Anyway, we'll discuss that just a little bit. Anyway, for more information, we do have a website called the Hawaii Climate Adaptation Portal. You can find a lot of good and useful information on that website related to climate change, climate science, what we're doing to make things better for everybody. At this point, I'm going to turn it over to Dr. Romine, and he's going to go over the science view, and then we'll roll that over into Dr. Portney. Thank you.
Thanks, Sam. Aloha again, everybody.
This is, I got to make this clear to people because it's important. This is not a plan. A plan is this document or this process to make some concrete changes to, like, you know, a development plan, right? It has discrete steps you're taking to like affect a change. This is a report, a technical report. It's meant to be given to decision makers so they can use the information to then make decisions whether or not, how they want to change things and whether or not they want to change things. So this is a little bit of a different animal than a typical plan that we're used to seeing.
This is the very famous CO2 record from right up the hill, Mauna Loa. Carbon dioxide concentration from the observatory up there, showing the increasing concentration of CO2 over the second half of the century up to the present. And you can see that we're now at about 400 parts per million, which is about 30% above the pre-industrial area background. CO2 is not the only greenhouse gas of concern. We've also increased methane, nitrous oxide in our atmosphere by about 15% as well. CO2 is a particular concern, though, because it's long-lived in the atmosphere. It can stay in the atmosphere for hundreds of years and affect our climate for a long time. Looking at quite a bit longer time frame here. This is looking back 800,000 years, and this is data on CO2 taken from ice cores, Greenland and Antarctica, actually taking the bubbles that are trapped in the ice cores and analyzing the gases in that. And what you see here is that the CO2 record varies naturally in sync with the ice ages. That's what we're seeing here on scales of 10,000s to hundreds of thousands of years. Up to the present here, where we now have pushed ourselves way outside of the natural envelope where the background was 250 or so parts per million, we're now up at 400 parts per million. So we're really playing with the climate system and pushing it well outside of the natural envelope here. And we see global average temperature moving pretty much in lockstep with the CO2 record. That's the CO2 curve, again, shown there in black. This is the average annual global temperature taken from temperature measurements all over the planet, year by year, back to the beginning of the century. And you see that steady increase. There is some natural variability in there from things like El Nino that lead to some of those wiggles in there. But getting up to the present, you can see that we've reached reaching new heights in global temperature. In fact, the 10 hottest years on record have all happened since the late 90s. And 2016 set a new record, as well as 2015 and 2014. That's the first time we've had 3 record years in a row. And I was just reading that July, they just confirmed, is the hottest month on record as well, and which actually is somewhat astounding because we've moved away from the influence of El Nino. Those 3 warm years may have had some relation to El Nino. We've now moved outside of that, and we're still smashing records, so it's very concerning. We're getting into new territory with temperature. Oh, many of you have also probably heard of the Paris Climate Agreement through the UN framework. That agreement intends to limit global warming to 2 degrees C, and if at all possible, 1.5 degrees C, with the idea that would hopefully limit any catastrophic effects of climate change. You can see from this plot we've already used up about 1 degree C, so we don't have a lot of room to play with left in that. We're talking about sea level rise today, but sea level rise is not the only climate impact of concern, but it's the one that at least the state through this interagency commission has decided to try to tackle first. This is a figure from the Pacific Islands Regional Climate Assessment. That was a contribution to the National Climate Assessment in 2012. It's a good read. They have an executive summary if you don't want to dig into the whole report. Definitely worth looking into. But they documented the different climate impacts that Hawaii is seeing now, and and the other Pacific Islands are expected to see in the coming future. Here in Hawaii and around the Pacific, we are seeing surface air temperatures rise, as well as sea surface temperatures. The oceans are taking up a lot of this heat and a lot of the carbon dioxide as well. That carbon dioxide is also changing our ocean chemistry and is a big worry for coral reefs and other marine life. We're also seeing marine and terrestrial habitats shift with changing temperatures and climate, seeing changing rainfall patterns and changes in our wind and waves and extreme event patterns as well. And yeah, again, welcome you to dig into that a little further with that report, but we want to spend most of our time on sea level rise today. This is the global record of sea level, average sea level for the last century. This blue wiggly line is the record from tide gauges around the oceans averaged together. And then the red dots and the green trend line is a more recent data set from satellite altimetry, a satellite that passes over the ocean in regular intervals and measures the sea surface height and takes an average of all the oceans from that. And what we see here is an observed acceleration in the rate of sea level rise around the global oceans. We've put this in an equivalent, these rates an equivalent of a rise per century. This is about 2 millimeters per year, but it doesn't sound like much. So we've done this to help understand what that looks like when you project it out of centuries. So early in the century, we're looking at about 3 inches per century. That roughly doubled through the middle part of the century, roughly 6 inches per century. Now, the last couple decades, we've gotten into a foot to a foot and a half of sea level rise observed from that satellite record. And so that's really kind of our baseline of what we expect to see over the coming decades for sea level rise. And we do expect that trend to continue, the rate to continue to increase, accelerate through the coming decades, where we get up to potentially 2, 3, even maybe more feet towards the end of the century. And we'll look at some of those projections for sea level rise. But first of all, what is causing this increased sea level? About a third of it is coming from thermal expansion of the oceans. That's just the water column. Water actually expands like a gas if you heat it up. Not as much, but to a certain degree, and that's actually a major contribution to the rise that we're seeing. Another third of the rise is coming from glaciers and ice caps on the continents and land masses. And another third is from the giant ice sheets on Antarctica and Greenland combined. And Greenland and Antarctica are the particular worry, and really a lot of the primary focus, a lot of the science of where sea level is going to go in the coming decades and centuries. And there's a lot of reason for concern with these ice sheets. Latest science is showing that a lot of the glaciers, certain areas of Antarctica and Greenland are starting to accelerate and melt faster than folks earlier believed. And this is a plot, two plots of Greenland, and this shows the decreasing ice mass overall in the ice sheet at Greenland. And actually you can see a little bend downward that the rate of ice mass is actually decreasing. And this is again from satellite data where they're actually measuring the gravity of that ice cap to understand what the mass is. So we see ice loss increasing in Greenland and a similar rate of ice loss going on at Antarctica as well. So that's one of the areas of uncertainty and really rapidly evolving science. And I think we'll learn a lot more in the coming few years about what's going to happen in that area, and is really helping to contribute to the evolving predictions about where sea level will go in the coming decades. So why is sea level rise a concern? Coastal erosion, first of all, that's already a major problem here in Hawaii. About 70% of our beaches are already eroding, at least on Kauai, Oahu, and Maui. Wave flooding, that's wave overwash along the coastline, already a major hazard. We get big waves, as you all know, here on all our coasts around the year, around the islands. Groundwater inundation is going to become a bigger problem. I'm going to show you some of the modeling we're doing with that, where as the tides rise with underlying sea level, actually pushing up the groundwater along our low-lying coastal plains. Drainage failure, backing up our coastal drainage systems, stormwater systems. And then more vulnerability from hurricanes and tsunamis. What this is really about is just adding additional water level underneath these storm surges or tsunamis. So increasing the impacts of those infrequent events because we have added water level when they arrive. Here is a projection of sea level rise out to 2100. This comes from the Intergovernmental Panel on Climate Change. Again, it's a body through the United Nations, probably have heard of. This is their 5th assessment report from 2013. And this is the projections we're using for our modeling and mapping for this sea level rise report. The science on sea level rise projection continues to evolve. I'll talk a little bit more about this, but there's two curves in here. The lower end scenario is this blue line, and that's their based on an emission scenario where we reduce our greenhouse gas emissions substantially in this decade. And it appears that we are going to blow right on by that target, that scenario. The red scenario is a scenario where we continue to add greenhouse gases at an increasing rate throughout the century. So they have a high end and a low end. We've opted to use, keep hitting the wrong button, sorry. This higher end scenario for our modeling for a couple of reasons. The first is just out of precaution. We want to see what's potentially vulnerable. The second is because, even in the 2 years that we've been working on this report, as I mentioned, science has really evolved, even to the point where what used to be somewhat of an extreme scenario has really become more of a mid-range scenario. And I'll show some more information on that. But with our modeling, we're modeling at these 4 sea level height steps, about a foot near the middle of the century and a little over 3 feet towards the end of the century, but there's still some uncertainty. It's not if we'll reach this 3 feet, it's kind of when. Is that going to happen earlier in the century, right at 2100, or can we do some really good job at reducing our greenhouse gases and stave that off until the later century, to be seen. And you can see that the curves are pretty tight around the middle of the century. More uncertainty as you get out to the end of the century, and that's typical with all these projections. Okay, so as I mentioned, these forecasts continue to evolve with the science. That IPCC curve has been criticized to a certain degree as being a bit conservative by some parties because it represents an international consensus of scientists and decision makers, and things maybe get a little watered down because of that. There's a lot of science and literature, scientific literature that's come out since then. One report that was particularly alarming, this is a quote from a NASA December 2015 report. Given what we know about how the ocean expands as it warms and how ice sheets and glaciers are adding water to seas, it's pretty certain we're locked into at least 3 feet of sea level rise. Again, the question is, when does that occur? And it's important to remember, too, that sea level rise does not end at 2100. That CO2 remains in our atmosphere, and this is expected to go on out into the next century, if not longer. Another report from NOAA that came out this year provided a range of scenarios. The IPCC projections we were looking at fell right in the middle of those projections. Their extreme scenario provided a physically plausible scenario of 2 to 2.7 meters of sea level rise by the end of the century. The probabilities with that are low, but the way the ice sheets seem to be behaving and the new science is coming out, it's becoming more and more plausible. And again, the science is still going on to better understand these higher end scenarios in particular. And I mentioned this, that, a lot of the science is focused on Antarctica and Greenland right now. Okay. I want to talk a little bit about the modeling we're doing based on the science to help try to map these hazard exposures and better understand our vulnerabilities around our coasts. We have 2 models that we're doing for Hawaii Island in particular. That's our passive flooding model and then our 1% annual chance coastal flood. As Sam mentioned, we do have a couple other models we're doing around looking at the annual high wave flooding, coastal inundation, and coastal erosion. Unfortunately, at this point, we're not able to provide those models for this island due largely to a lack of historical data on erosion trends at the beaches and coasts, but hopefully something we can get together in the future. Again, this is meant to be kind of a living document, living report. So the first model is this passive flooding model. This is often referred to as a bathtub model. This is done in geographic information system software. You basically take a digital representation, a digital model of the coastal topography. You calculate typical high tide level, and then raise that surface at our increments that I showed you in the sea level rise curve over the coastal topography, and looking at what areas along the coastline would be directly flooded by marine inundation. And you also get areas in the backshore that are low-lying that will also be flooded by indirect flooding from the groundwater table. As that water floods the coastline, it also causes your water table, that fresh and saltwater lens, to rise under the coastal plain there. So you get water cropping out in the backshore, effectively creating new wetlands where it becomes permanent, or also blocking out the drainage when we get increased rain and storms. And Dr. Courtney is going to show us some example maps from around the island for that in a little bit. The second model we're doing, this is more of an event-based hazard. This is our 1% annual chance coastal flood model. It's event-based as opposed to the other model I showed, which is more of a chronic flooding hazard. This is often referred to as the 100-year flood as well. This is what, if you're familiar with the flood insurance rate maps, that's what we are modeling here, but with sea level rise underneath that as well. So we're taking the 1% still water elevation and then adding these sea level rise increments to them, and basically producing a new version of the flood insurance rate maps. It's not something that will be directly adopted necessarily yet for flood planning, but something that the county can think about if they choose to. And then modeling the 1% annual chance wave and storm surge on top of that. So it's something that could be used by the counties and the state for an overlay on top of the existing flood hazards to look at additional flood worries. So I don't need to cover this. Just real quickly, I've already touched on this. We're doing this modeling, hazard modeling. It varies a little bit among the islands, what we can provide for each one, but we are producing a vulnerability assessment for each island and taking this hazard data, overlaying it on information on property values, demographic information on coastal, on shoreline cultural sites, and doing a vulnerability assessment from that. And I'm going to pass it over to Kitty, and she's going to talk some more about the vulnerability assessment and report development.
I just want to make a quick announcement. I forgot to mention Lauren Yasaka is also here from Oahu. She's one of our planners in OCCL. I also wanted to note that this is being tape recorded, so we'll have a record of it, but also just to, because if you're going to be speaking, you're going to be captured on the tape recorder. I want you to know that. And I want to thank my boss for coming. Bob.
All right, good evening, everyone. So I'm going to build off what Brad has talked about. He talked about the two types of modeling and how we use that now to assess our vulnerability. So just a reminder that vulnerability, this is kind of a simple vulnerability equation. It's the result of exposure and sensitivity to harm, and this results in potential impacts. And I want to emphasize potential because this is, we're looking at projections and we're trying to overlay this and get an idea, a kind of a baseline of where we are. And then those potential impact can be offset by our adaptive capacity. If we have low adaptive capacity, these impacts are greater, will have an effect. And so what I'd like to talk about tonight is the sea level rise exposure area, which is the passive flooding that Brad talked about. It is the chronic flooding. It's something that will happen slowly, over time, have more permanent effects, like, it's going to result in more permanent loss of structures and land. Then I'm also going to talk a little bit about the 1% annual chance coastal flood. And when we model this, we are able to incorporate things like the type of building structure. Is it elevated? Is it on slab? What's it made out of? And that running the models with that information helps us understand not only the exposure but also the sensitivity to the wave inundation. And then lastly, I'm going to show you some maps of these areas and some of the economic loss numbers, as well as you're going to get to see, you're the first group to see the statewide comparison of all the islands, because this has just been finished. And then later I'll talk a little bit about some of the recommendations that will come out in the report. As Sam mentioned, this is not a plan, it's a report, but that doesn't mean that we don't have recommendations. So we will be providing some of those recommendations based on what we've learned from this vulnerability assessment. So first of all, the sea level rise exposure area, again, this is for the Big Island, will be based on passive flooding only. And it's the it's a more or less permanent feature that we're looking at. And there's a number of assumptions. It's chronic, permanent loss of land structures and displacement of people. These are assumptions we're making. If nothing happens, if we don't do anything at all, if we make no changes and we don't take any action, these are the kinds of things that we might expect. And also the potential economic loss, which is based on land and structures from the current TMK values, the tax map cube database that we get from the county. And it doesn't include basic utilities like and roadways. We can estimate and determine the vulnerability in terms of miles of road or feet of sewage line impacted and those things, but we haven't monetized that. So I just want to note that that's kind of a big chunk of money that we don't know the answer to, okay? And we don't know how all of this might help, what impacts it might have on our economy or you know, visitor industry or any of those things. These are the unknowns, so I want to make sure that's clear. Okay, so let's get to, we'll start with a map here. This is Kailua Kona. This is with 1 foot of sea level rise. So what you see here is the land, and you see this blue zone. This is the sea level rise exposure area. This is passive flooding, the chronic flooding with 1 foot and then with 3.2 feet. And it's not easy to show some of these things on maps because in some cases, as this one, it's quite a thin line around the edges. The Big Island is got a lot of rocky shoreline. Its topography is different than, let's say, Oahu, which when you see the comparison in a minute, you'll note that you know, Big Island is a little less exposed to some of these impacts. So this is just an example of a map. And then here's another area in Puna. Here's the Isaac Hale County Park. Yeah, and this is 1 foot of sea level rise. And then when we get to 3.2 feet of sea level rise, you can see this red area. This is where the road will become impacted. So potentially there could be chronic flooding of that roadway, which might need to be addressed. It's okay. Here is an area, Kapoho. The red dots are septic systems.
You got that one? Good.
I'm sorry, I'm stepping right in front of you. And so one of the other things we're looking at is, I mean, we're trying to look at as many variables as we have access to from the county and state databases. So where we have septic systems, where we have cultural sites, where we have you know, our roads and so forth, and making an accounting of these. But of course, if some of these septic systems become exposed to seawater, they'll not function properly, and we could have some impacts to nearshore water quality down the road, as well as inconvenience to people who live there. This is how we show the economic loss for the chronic flooding, the sea level rise exposure area. These little squares, each one of them is 1 hectare, or about 2.5 acres. The analysis that we do is actually at the parcel level. So we take all the parcels and do the analysis, but then we overlay the grid system and, you know, kind of roll it up into these little squares, right? So what this tells you is that, remember before I showed you the blue area, right, of flooding? So this is showing you a different view of that, but from more of the economic loss. Again, this is due to land value and structure value only. So you might have these light yellows are less than 250,000. The darker red one is 10 million to 50 million. Just to give you an idea of where these losses and what the magnitude of them. And this is with 3.2. Waikoloa, Puako. Here's the summary for the Big Island. And as Brad said, we've looked at all these different, you know, 0.6 feet, 1 foot, 2 feet, 3.2 feet. But, you know, ideally, we're just kind of saying, okay, 1 foot is pretty much where we could be very soon. And we're looking at 3.2 feet as something that we should really be paying attention to. So here is the about $430 million in structure and land loss. 130 structures flooded, 1,900 residents, 2 miles of road. And this gray with the question mark is that unknown economic part that I told you about that we can't estimate. And we wanted to make sure that we put it there with question marks so people don't forget that there's a lot of impacts that we haven't estimated economically. So this is what that looks like, and here's the 1 foot. But when you start looking at the statewide, it's quite different. At the top, those blue little shapes is the acres flooded in the sea level rise exposure area. So on the left is Kauai. It's about 5,700 acres. Next, the big one is Oahu, 9,400 acres. Then Molokai, Lanai, Maui, Big Island, 4,500 acres. But when it comes to economic loss, again, Oahu, because it's so densely populated, because we have so much assets very close to the shore, 12.9 billion. And when you look at the total statewide, if you added these up, right, it's 19 billion. So you know that it's Oahu is the big one that's causing most of that, right? You know, overall, statewide, 116 miles of roads, 6,500 structures, 20,000 people. These are estimates, okay? This is not a hard, fast number. These are potential impacts. And as we know, the science is changing, and that this is a living product. Over time, these estimates will need to be updated. Brad mentioned, I just want to show this to you because Brad mentioned earlier that some of the new science that's coming out is pointing to higher than our 3.2 feet, as plausible as 6 feet of sea level rise, even as early as mid to the latter half of the century. So what we did is we did not model 6 feet of sea level rise in all this. This was not, when we first started the project, 3.2 sounded pretty big. And this, over just a couple years, we've seen some dramatic changes in the ice sheet melt. So what we did is we took NOAA's sea level rise data viewer. They do the same kind of passive flooding. And we took that and we just said, what does 6 feet look like? How much more would be added, just as a rough estimate, to our area of chronic flooding? So on Oahu, it more than doubles the total area. On the Big Island, it's not as much as another quarter or so more. So we wanted to also in the report, you know, just give a nod to that there is some changes coming and that we should be thinking about those. Okay, the last one I'm going to talk about is this 1% coastal flood zone. As Brad mentioned, this is what we typically think of as our FEMA flood zone, our V zone. If any of you live in that area, you'll know that you are required to have flood insurance. If you aren't in that area, you know, or in a flood zone, you don't have to have flood insurance. And I don't know if you follow, but in many parts of the United States, when flooding occurs, there is a large percentage of people who have flood damage now who aren't in the flood zones because of these changes in climate and weather patterns and so forth, and therefore they don't have flood insurance. So we want to model this, and the other thing I will note that because by law, by federal law, FEMA is not allowed to model future conditions. They can only model historic conditions. They can't project a different situation. This is the part of the federal law. So what we're doing here is taking that projection of based on historic conditions, and we're lifting that projection up and modeling it with sea level rise so that we can kind of see what it might do. The loss is based on the cost to repair or replace the structure and contents, again with the tax map key values. And don't forget that with these very infrequent but very severe events like hurricanes, and this even includes tsunami modeling as part of this 1% kind of event. It doesn't happen the same on every part of the island, you know, or even in all the islands. So that's another assumption, that we're showing it as if it were occurring uniformly everywhere. All right, here's Hilo. And actually, I'll show you in a minute. So what this shows you is just this is with 3.2 feet of sea level rise. This is schools, this is one police station here. But you have a lot of infrastructure outside, but then there's, you know, because Hilo has thought about this from tsunami too, that you've left some green space and haven't developed as much right along the coastline. So while there are impacts, you know, it's probably better than some places. Now I'm going to overlay the FEMA zone, and it's kind of hard to tell the difference. This is a little bigger, but not that much bigger, okay? So that's what this looks like. So this red zone is the V zone, and you'll see that. You can go to the flood map zone website that DLNR has, and you can see that. You can go and find this data there now. So what we did again is try to show it, add the sea level rise. And so you can see there's a bit of an extension. What it'll be is a bit of an extension on this landward side. Again, here's Kailua Kona, are just a few little economic impacts with 3.2, a little bit more. Not as much as when we have to show this kind of information on Oahu or Maui in some places, but still there are impacts. Island summary, about 110 million with 3.2 feet of sea level rise, so the impacts are greater than that chronic flooding from an event. This is event-based. 470 structures, 30 miles of road, and so forth. So all this information will be in the report. And again, we can compare it across all the islands. This is the big one, 120 billion from an event-based hazard on Oahu with 3.2 feet of sea level rise. And most of that comes from Oahu, right? The statewide, this is statewide, where 120 billion of it is from Oahu. So you can kind of get a sense with looking at this, at how the different islands will be impacted. A lot of it has to do with the shape, the geology, and the geography of the island. A lot of it has to do with how development is concentrated along the coastline, right? The more concentration of that development, the higher the numbers. And some of the things that, what kind of measures that the different counties have taken to improve your capacity to adapt. Hawaii Island is part of the community rating system. Do you know that? You and Maui. And under the National Flood Insurance program, if you are part of the community rating system, you get discounted insurance rates. And it means you're implementing a higher level of improving your, reducing your flood risk. You're doing things that give you that rating. So that's good. Now we just, you can boost your rating maybe by looking at other things but Oahu is not in the system. So there's a lot of opportunity for Oahu to help improve, to help get this discounted rates for people, because flood insurance is not a bad thing to get. Now I'm going to focus a little bit now, just a couple of last slides on the recommendations. As Sam mentioned, we had a lot of discussions, meetings, workshops, literature review. We looked at all these types of information. We looked at what other states are doing, what other people are doing, trying to come up with a really good, robust list of recommendations. And we've come up with this 10 kind of top recommendations, and these are kind of big pieces, but when you see the report, there are very more detailed elements, and I'll give you some examples in a minute on these. But I just want to kind of tell you that at the core of it is really to support sustainable and resilient land use and community development as being kind of this real, where the rubber meets the road. We need to do a better job of figuring out how we use our land. We need to overlay these hazard areas and see, well, what do we have left? What's usable once we've done this? And how do we work with our community development planning process and the county general planning process and all these things to really do our land use planning and our community development planning more robustly to support sustainable and resilient use. Supporting this is limiting new development in these areas where we have known hazards. Also, maybe thinking a little different about how we develop, supporting or prioritizing more smart urban redevelopment, looking at more dense, a little bit more density, having more open, which enables more open space that has, walkable cities and these types of things that can be incorporated. And this number 4, again, is supporting this improved flood risk management. This has to do with a lot of FEMA requirements that we could take advantage of that we may not be doing now. Updating our hazard mitigation plans to make sure that they have sea level rise. Adopting some of these flood zones as overlays so that we can start improving. Then surrounding those are, we need a plan and some strategies to keep our beaches. As beaches are migrating, they're running up into structures, roads, properties. So if we want them, if there's some places that we just really don't want to lose, we have to figure out, do we have to acquire some land? Is the backland, we have to allow some migration of that beach back if there's appropriate, say sand deposits back there and so forth. So we need to think about those things. We also need to, we talked about that septic tank issues, protect nearshore water quality, preserve native Hawaiian cultural resources, and come up with a culturally based adaptation strategy, because many of these resources can be located right in the coastal area. What is the appropriate response? Is it to allow them to stay there, to relocate them, and so on? So these are some of the things that need to be thought about. And then supporting all of these is really, we need to develop a very robust funding sources and incentives to help make these things happen. We need ongoing research, assessment, and monitoring, and we need a much more collaborative process for adaptation. Even at the county level, we talked today to many of the county directors about, well, the floodplain manager might be in PWC, and the long-range planners are here, and these guys are over here. We need, much more collaboration amongst our government, both within a county and state, but also across. So these are kind of the big picture of the recommendations, and there will be a lot of details in the report. And just to kind of give you some sense, some of the ones I just threw in, it's we need to integrate exposure to sea level rise in the community development planning process. How many of you are involved in community development planning? These are things that I think will be helpful when we start thinking about that. Require mandatory disclosure of these hazards in property sales. Right now, pretty much the disclosure is just like one row of houses right at the edge. And as you can see, that's probably not a really adequate. Maybe encourage property owners outside of the FEMA zones, which require insurance, to start purchasing insurance. And so, and then providing that support to that community rating system program so that either you can boost your rating and get even lower insurance rates or become part of the program, like Oahu and Kauai. And then, of course, we need to start right away thinking if there's any capital design improvement projects on the books, we need to think about, should we put them there, or how should we build them? Do we need to fortify certain areas that maybe we can't move? I don't know, look at Honolulu runway there. Maybe we can't move that. What do we do with that? And how do we, So these are the kinds of things that will be in the report, this recommended next steps, and I think that's, last little bit. Through another project that Brad and I are working on, funded by NOAA, and a community resilience grant. There's some money for the Pacific Island Ocean Observing System, PAC-IUS, to develop an online tool where all this information, these maps, will be visible. So you can go to it and, you know, the report, we can't put every single inch of coastline to show where everybody's interested in looking. So we'll have examples, but then you can go to this website and say, oh, I want to see where my area is. And you can zoom in and take a good long look at that. So anyway, that'll be available when the report comes out. So thank you.
Okay, questions, comments, concerns?
Thank you. My name is Bill Hansen. Usage that we've done on the coastal areas of the islands that maybe wasn't well thought through. And this will be possibly a way that we can leverage that, take a look at it again and say, did we do a good job or do we need to do some improvements now on the infrastructure that we have around the coastal area, whether or not, regardless of the sea level rising or not. The thing is also I'd just like to say if we could maybe consider, it appears that it gives kind of, the report maybe might have the taste of we're the villains in sea level rising, and that might not be the case because we're just like every other animal or part of the biosphere that lives here. There's a lot of also erosion. We can just take a look at the bathymetry models or maps of the islands, and you can see there's a lot of erosion that's happened over the thousands or millions of years. It's a naturally occurring thing. There's also a lot of land and salt that goes into the ocean over the years through the rivers, the streams, just the coastal areas eroding away. But that's never talked about. We take a look at the villain component of us, and we're the bad guys in this. And we may not be the bad guys here, is what I'm trying to say. We may be the superheroes in all of this. It just happens that over the years, we have said that we want to live more in the coastal areas. If you turn off all the lights, turn off the sun and then turn on all the lights, you'll see that the majority of people around the world want to live on the coast versus inland. And that wasn't necessarily where we lived when we were less technical. We lived inland because we knew you don't live on the coast because you're going to get dinged by the wave or whatever. But we want to challenge Mother Nature. The other thing is just the science in this. I know that you had mentioned, Brad, that the Antarctic, ice cap, there's some issues there. But I just saw a report in 2015 from NASA that contradicts that. And I don't mean to contradict Brad. I think Brad's great what he's doing. But there's science out there and then there's science out there. Science fiction or whatever. But this report, just really quick, I'm sorry, just to read it. This is from NASA, 2015, and it says, according to the new analysis of satellite data, the Antarctic ice sheet showed a net gain of 112 billion tons of ice in a year, per year from 1992 to 2001. And a net gain slowed during 2003 to 2008 to 82 billion tons a year. So it's gaining 82 billion tons of ice a year, according to this report right here. We have scientists that say yes, and we have scientists that say no. Science should be exact. It should be 1 + 1 = 2. But we have two camps out there that say differing information. There was also a picture there that showed vacation land, Kapolo Beach Lodge, and it showed the water level was such and such, but that was because there was a subsidence. In 1975, there was an earthquake, and the land dropped 0.8 feet. So it's kind of misleading if we show, hey, we're showing that picture, but we should qualify certain things, and it just isn't fair if we're switching things around just to try to prove a point. And all I'm trying to say is we don't have to prove those points because, yes, we have to do these things. We have to look at mitigation. We have to look at coastal erosion.
Thank you, Doug.
Thank you.